Okay, Assalamualaikum and very good morning to all my students, especially for the section 1 and also the section 2. So for the industrial engineering subjects. So today we are going to learn about a new topics. So still in the topic chapter number 2. So chapter number 2B, I will say that is call it as a line balancing. Okay. So please see my in front of these slides. So this is line balancing. Okay. So what is line balancing? So later on, we are going to learn definition and also how to conduct the line balancing itself. Okay, so what is line balancing? Okay, line balancing is the assignment of the task to the workstation. Okay, so basically in a line. So what the objective line balancing? So we want to achieve a desired output rate with the smallest number of the workstation. So this is the definition of the line balancing. So procedure in which tasks along with the assembly line are assigned to the workstations. So each have approximately same amount of the work. Okay. So line balancing is one of the assignment tasks to the workstation. So in order to achieve a desired output, okay, with a smallest number of the workstation. So this is a definition of the line balancing. So in order to calculate, okay, to determine what are the line balancing performance measure, so we have to calculate the cycle time. Okay. So this is a formula cycle time. Please copy down first, where the C is stand for the cycle time and R is a desired output rate. So by definition, what are the desired output rates? So stand for the small r. Okay. Desired output rate is ideally is measured for the production planning. Meanwhile, for the C, or we call it a cycle time, is maximum operation time allowed for the each of the workstation. So single workstation meaning that. Okay. So in order to calculate this cycle time, so this is a formula. Cycle time equal to 1 divided by R. So R is stand for desired output rates. C is a cycle time. So please remember this formula. Okay, clear? Okay. And then in order to calculate the theoretical minimum number of station, or we call it a TM. Uh, eh? So TM is not a Telecom Malaysia. This is theoretical minimum number of station. This is a formula. So please copy down first. So in order to calculate the theoretical minimum number of stations, so divide by sum of the T. So what is sum of the T here? The total time required in order to assembly each of the product or unit or part. Okay. Meanwhile, for the C is a cycle time. So the formula will be on the TM equal to sum of the T divided by C. So this is how we want to find out the theoretical minimum number of the workstation. Okay, so this is number 2 formula. Previously is a number 1 formula. So please copy down number 1 and number 2. Okay, so copy down just a simple things. Okay, and number 3, how we want to calculate the line efficiency and balance delay. So there are two type of the formula here. Okay, the first one is a line efficiency, and the second one is the balance delay. So how do we calculate the line efficiency in percentage? So equal to sum of the T. Sum of the T is total time required. Okay, and divide by TM times 2C. And you need to times 100. Okay, so sum of the T, total time required, okay, divide by theoretical minimum number of station and times to cycle time. And you have to times with 100. Why 100? We want to get the in percentage value. Okay, So this is basic formula. Please copy down. Meanwhile, in order to calculate the balance delay, okay, in percentage, so we just only simple things 100 minus 2 line efficiency that we get from the our above formula. That's all. So line efficiency, we'll get this number. Then balance delay, we have to minus with 100. Then we get the balance delay in percentage. Okay, so there might be formula number 3 and formula number 4. So we have a 4 formula here. Okay, done? Okay, good. Okay, in order to calculate the idle time. So what is idle time? Idle time equal to the Tm times to C minus to sum of the T. This is number 5 formula. 5th formula. Okay, so this is the minimum number of station. This is our cycle time. And this is our sum of the T, total time required. Okay, so only 5 formula we have here. Okay, clear? Done? Okay, good. Okay, please copy down this example that I give it to you. Just copy down the important things. In which in table. So I give it to you a 2 minute or 3 minutes. Don't worry. Okay. Please copy down first. Work element A, B, C, D, E, F, G, H, I. So we have here work elements, and each of the work element A, B, C, D, H until to I, we also have the assembly operation or description. And each of the work element, they have a time, seconds, and each work element also have immediate predecessor here. So each of the work element, for example, A. Okay. So I give it to you, for example, A. Okay, A. So A, what is the work element for A? Bolt leg frame to the hopper, the process. So how many minutes or time required? 40 seconds. So is it any immediate predecessor? None. Okay. Then we go to the B, work element B. So what is the type of work element B description? Insert impeller shaft. So what time required in order to complete this assembly operation? 30 seconds. So any immediate predecessor? Yes, A. So each of the work element, they have their own time seconds, okay, and own immediate predecessor. So in order to calculate all these things here, okay, this is some of the our T, total time required, will be 244. So we have to plus 40 plus 30 plus 50, 40 until 218. So we will get sum of the time required to assembly is 244. Okay, clear? Just simple down, don't worry. I give it to you a slide note. Okay. So we begin on one by one. So this is a green grass. Okay, is a manufacturer of lawn and garden equipment. This is lawn and garden equipment. It is designing assembly line for the new fertilizer spreader. Okay, the big broadcaster. Okay, so they design an assembly for the new fertilizer spreader. They call it as a big broadcaster. So using the assembly process data, construct the precedent diagram. What are the meaning of precedent diagram? So later on we talk about this thing. Okay. So first thing, we have to construct the precedent diagram for this big broadcaster. So how do we construct or draw or sketch the precedent diagram? So one by one should be like this. Okay, done. Copy this from a question. Okay, clear, eh? Okay. So let's say the question we need to create or draw sketch precedent diagram first. So this is existing data that we have based on our question ni. Okay. First thing you have to draw like this. First at all, we start with A. Please remember, make it a circle here. Okay, and put a A here, and put a number time seconds will be in below of the hour circle. A 40 here. And then we look at, is it any immediate predecessor? None. So this is meaning that a singles. So A first, 40 here. This is our first work element in process. Okay, clear? Okay, clear. And we look at on the B. Look at on the B. B is insert the impeller shaft. Okay. So in order to get a B, we look at on the immediate predecessor. So what is immediate predecessor for the work element B? So A. So you have to draw a line here and draw the circle B and put it on the number of time second required 30. So why? Because immediate predecessor is A. Clear? So look at on the immediate predecessor. It's very important in order you calculate or you construct the precedent diagram. Okay, for the C, can you guess? The Excel else ni 50 second. So immediate predecessor will be still A. So in which? So we have to draw like this. A to the C. C will be here. Don't worry about the arrangement of our construct precedent diagram. So you can put here and also here. So don't worry about the shortened arrow here, the longest arrow here. Okay. So please draw A, B. B is immediate for A. C immediate for the A also. So we also have two type of the immediate predecessor based on the work element A. Okay, clear. Okay, done. Any question so far? Okay. And then we look at on D. Attach agitator 40 second, in which immediate predecessor B. So which one B? Here. So we have to draw again until like this. So D will be here. Make it a circle and please put it on the time seconds. Okay, 40 second here. And the rest. So look at on the E. Attach drive wheel. So B here. Attach here. E. Okay. So 6 seconds. So don't worry about the arrangement. So just construct with a correct error here. Okay. Okay. And we look at on the F. Attach the free wheel. 25. So look at on the immediate predecessor. C. Which one the C? Below here. So we'll draw like this. Okay, for the F. And for the G, mount lower post. 50 second required. Okay, immediate predecessor also C. So which one? C. Also here. So please make it a circle and please put it a value number times second below on the circle for each of the work element. And the others for the hash. Look at for the hash. The required immediate predecessor, D and E. Which one D and E will be here? D and E. So we will get here hash. Okay. And last but not least, I. Mount nameplate will take about 18 seconds. Okay, so the immediate predecessor is F and also the G. So lastly, we also have get here. So we also have this a proper line or what we call it as a construct a precedent diagram. Okay. So the most important thing, look at on our immediate predecessor when we construct a precedent diagram. So please make sure you follow from the basics thing. So each of the word element, they have their own immediate predecessor. So please double check. A, B, B, C, C, D, E, F, and G. Okay? Any questions so far? Don't worry about the arrangement, doctor. How can I arrange from A and B also like this? Or B, F, G, G like this? Can. Don't worry about the arrangement. As long as you draw based on our immediate predecessor. Okay, clear? Okay. Any questions so far regarding to our precedent diagram? Easy, right? Okay, good. Okay, so right now we also have this. Okay, if you draw like this, might be 3 marks. Okay, based on our depend on our question. Okay, so this is a precedent diagram. And number 2, please copy down this example first or question. Okay, so just copy down the basic value, what we the important data in which 2,400 spreader per weeks for at least 3 months, and plan will be operated at 40 hours per weeks. Okay. Okay, I give it to you 1 minute or 2 minutes. Don't worry. I'm waiting for you. Okay, done? Okay, we begin on our next example. This is continue. So still same the question. So the first one, we have to construct a precedent diagram. Okay, then the second question, okay, they give it to you. A green grass plant manager receive marketing latest forecast for the brick broadcaster sale for the next year. So she want a production line to be designed to make a 2,400 spreader per week, at least for the next 3 months. Okay, so the plan will be operate 40 hours per week. So the question is, what should be the line for the cycle time? Please remember what the formula of cycle time. Cycle time 1 divided by R. Please remember. And number B, what is the smallest number of workstation that she could hope for a designing line for this cycle time? And what would be the line efficiency? Okay, so we continue our step by step. Okay, clear? So we look at on the A first. Okay, this is our they given to you based on our question. They given to you 2,400 per weeks. This is a desired output rate. Okay, please remember. Okay, and they give it to you plan operate 40 hour per weeks. Okay, so where do we get this number? So it given to you in our question. 2,400 spreader per weeks, and this plan operate 40 hours per week. Okay, clear? Okay. Then, okay, how do we calculate to find the output rate? So R equal to 2,000 per weeks, okay, divide by 40 per weeks. So we will get 60 unit per hour. Okay, in simple term, okay, 2,400. Okay, 2,400. Okay, per weeks, weeks here. Okay, and then you have to divide per weeks, Oh, sorry, per weeks. Okay, and we have to divide 40 hours per weeks. Okay, and week cross week here, so we only left hour, unit per hour. So 2,400 divided by 40, so we'll get 60 unit per hour. Okay, this is our desired output unit per hour. So is it we need to find out the hour, or we need to find out in our seconds for the line balancings? So we look at on the next step. Okay, this is our formula cycle time 1 divided by R. So we get the desired output rate, R will be 60 unit per hour. So 1 divide by 60 unit per hour, so we will get 0.0167. Okay, is it correct? Please double check with your calculator. Then from hour to unit times to the how many hour in second. So 1 hour, we will have 3,600 second. So cross hour, so we'll get the hour line cycle time is 60 second per unit. So why we need the line cycle time is second per unit? Due to our work element. Look at on our work element here. So they give it to you work element in seconds. So we find out in seconds. Okay. Any questions so far in order to calculate the cycle time? So they given to you this one, desired output rate and plan operates. So you have to find out the R first, and then you get the 60 unit per hour. Then from 60 unit per hour, so you have to 1 divide by R. Okay, 1 divide by 60 unit per hour. Okay, so you will get 0.0167 hour per unit. Okay, so we need, is it we need in hour, a unit, or is it we need a second? So we need a second per unit. So convert from hour to the second, from hour to the seconds. Okay, and then you will get 60 second per unit. This is our C. Any questions so far? Don't worry, I will repeat as long as Astro, macam Astro TV. Okay, any question so far? Good? Okay, clear. And then we look at on our next. How do we calculate? We also have this 60 second. Please remember, cycle time 60 second per unit. Then how do we calculate the TM? This is TM formula. Theoretical minimum number of station. So total of the sum of the T divided by C. So how we get the 244 second? Divide by 60 second. Which one? We get total sum of the T. So previously, look at on our existing data. This is our total T. Okay. So we calculate all these things from work element A until to work element I. So we get a total sum of the T, 244 second. So put it here, our 244 second here. Okay. And C, what will get the C? C, we will get the 60 second. So we cross second, so we will get 4.067. or we made a nearest one is 5 workstation. So meaning that what is a 5 station? This is a 5 station that we need a theoretical minimum for the number of workstation. Okay, let's see if you get the 4.1. Okay, so the nearest one is 5 workstation. Let's say you get 3.92. So what will be the number of workstation?
Four.
Anyone?
Four.
4 here. Okay, correct. If we get 2.10, so which one will be 3? Yes. So it's based on our nearest one. Okay, so meaning that TM, we get the 5 workstation. So looking on our Trichum number, so we get 5 station. And how do we calculate the line efficiency? Just put in our formula. So line efficiency percentage will be sum of the T divided by TM times to C. Then, okay, times with 100. So just put on this value. We get a 244. Okay, TM will get a 5. Cycle time we get 60. And we need to times 100. So the final answer we will get 81.3 percentage for the hour line efficiency. Okay, clear. How do we calculate the balance delay? So if balance delay. Okay, balance delay. What is the previous one? Formula balance delay. So we recap again. Okay, which one? This one. Balance delay. We get the blind balance efficiency. So how we calculate the balance delay? 100 times to line efficiency. So the balance. Okay. Okay, the balance one. Which okay. Here. So balance delay. Okay, balance delay. Okay, will be 100 minus to our line efficiency. So 100, if the question asks you how to calculate balance delay, so this is how we calculate 81.3. So we will get balance delay, we will get 20 or 19, 19.7 percentage. Okay. So this is how we want to calculate the balance delay, for example. Okay, clear? Easy, right? From the previous, if we compare with the mini-sum model, our transportation model, and also our break-even analysis. Okay. And then after you calculate here, so we will get our what we call it, this one. So you get a cycle time. You will get a TM 5 workstations, and then you will get the efficiency 81.3 percentage. So how we do the balance from the our data above? Okay, so we need to grouping by the group of number of station, meaning that TM. Look at on the TM. So TM only need 5 station. So look at on the C, in which cycle time is 60 seconds per unit. Okay, so how do we grouping based on our TM? First, we have to draw this table first. So please draw the table, copy down first. We have the station, candidate, choice, cumulative time, and also the ideal time. Please draw. Okay. Okay. So we want to find the 5 workstation. How do we calculate grouping the 5 workstation? So later on, I will discuss for details. So far, any question? Any question you want to ask? No question? Okay, good. Alhamdulillah, meaning that you fully understand what I'm teaching. So in order to understand, I give it to you a tutorial regarding to our line balancings. As usual, you have to submit. Okay, done. Copy this station, candidate choice, cumulative I time, and also the ideal time. So we proceed on the next step. Okay, the first one. Look at on our precedent diagram first. Okay, so this is station 1. S1 is station 1. So if we have any candidate here, so look at on the our candidate. We're starting from the A. Uh, this is A. Okay. So candidate A. So any choice between any candidate C or B? No, because this is the first line. So A. So the choice will be A. So what is the cumulative time? Cumulative time is based on our second time. So we look at on the our 40. How do we calculate the ideal time? So in order to calculate the ideal time, so we need to 60 our second, okay, minus with 40. So we'll get a balance 20. This is our ideal time. Okay, this is the first thing that you have to know. Okay, the station 1, candidate A, choice A, cumulative time is 14. Okay, 14 here. And then the ideal time is 60 minus 2, 40. Okay, clear. Please remember, okay, please indicate that cumulative time. In order this cumulative time, based on our rule, okay, so please draw green here, is based on not less than, not more than, not more than our, or not more than 60 second. So this is how we get this number as a guideline. Okay. Okay, is it any station number 1 that we can add on? If we 40 plus 50, it will be 90. So more than 60 second, more than on the second time. Is it any A and B? So 40 plus 60 will be 70, more than 60 seconds. So the first choice, session number 1, only this thing. So put here like this. Whether you want to draw like this, okay, make it a circle, make it a grouping. This is S1, station number 1, which is grouping only single A40. So we look at on the session number 2. Okay. So session number 2, what we have the candidate. Look at on the sequence B and also the C. So the candidate will be B and C. They have a 2 candidate in which B will be 30 second. Meanwhile, for the C, 50 second. So based on the B and C, which one the higher one? Which one they have the higher value? 50 or 30?
50.
Will be C. So the choice will be C. So our cumulative time is 50. So where we get the cumulative time? Based on our work element here. Put it here. So how do we calculate the ideal time? 60 minus 50. Okay, so we'll get 10. Okay. Is it any candidate? If we just left B, for example, B will be 30. Is it 50 plus 30? 80, right? So more than our second cycle time. 60 seconds per unit. So only session 2 only C as our station number 2. This is number 2. Okay. So session number 1 we will get 40. Session number 2 will get 50. Okay, clear? Okay. Okay, we need to find out our session number 3. So what do we left here? Okay, any candidate here? A, done. C, done. So until now, B, F, G, only left. So candidate B, F, G. In between B, F, and G, which one have a highest numbers? So it will be definitely B. So the first thing is B. So cumulative time is 30. So balance is 30. How do we get the balance? 60 minus 30. So we will get 30 for the idle time. Okay, clear? Okay. Clear? And
Yes.
then, okay, look at on the next step. Okay. Look at on the next step. We also have the left E, F, G. B, A clear, C clear, B also clear. So E, F, G. Which one E, F, G? E6, F, and G. So in between E, F, and G, so which one have a highest number? 25, F. So put F here. So how do we calculate the cumulative time? 30 minus with F, 25. So we will get 55 here cumulative. Okay. How do we get here? 30 plus 25. So we'll get 55. So what the idle time? How to calculate the idle time? Okay. 60 minus 55. So we'll get 5 idle time. The up to date here. Okay. Clear? Is it 45? Is it cumulative time more than 60 second? No. Okay, less than 60. So we proceed. So the first session number 3 will be B and F. This is session number 3. Okay, B and F. Okay, clear. B and F. Okay, and then we look at on the session 4. Session 4. Okay, so what do we left here? D, E, and G. D, E, and G. So in between D, E, and G, which one have the highest number? So will be D, 40. So the candidate choice is D. So cumulative will be 40 here. So the balance idle will be 20. So once again, how do we calculate the idle time? 60, okay, minus 2, 40. So we'll get 20 number for the idle time. Then, what we left here? E and also G. In between E and also G, which one they have the highest one? G. So we have to choose a G here. So G 15. How do we calculate the cumulative time? 40 plus our G 15. So we will get 55 cumulative time. And how do we calculate this number 5? So 60 minus 2, 55. So we'll get 5 number. Okay, clear? Easy, right? This is our session number 4. So this is our session number 4. We also have session 1, session 2, session 3, session 4. How do we calculate the session number 5? Okay. In order to calculate session number 5, what do we left here, our work element? Only E and I. E and I, and also hash. Okay. You can put it E, I hash here. Okay. Which one you want to locate first? It's based on you. Okay. For me, I will locate which one the highest number. 20, 6, and 18. Which one? Might be hash first. Okay. Okay. Let's say I give it hash here. This is hash. So what the number of the hash here? Hash will be 20, right? Please, this one is 20. So how do you calculate the idle time? So we have also here in our 60 minus 220. So we'll get 40 here. Okay. So what we do left here, E and I. So in between E and I, which one the highest one will be? This one you have to erase. I, for example. So I will be 18. Right. 20 plus 18. So you will get 20 plus 18. So we will get 38. So what are our this one? 60 minus 38. So what we'll get here? 22. And last, what we have here? Hash I, E last. Okay, so E. So the candidate is E. So E, what the number of E? E will be 6. Okay, so how do we calculate here? Okay, 38. Okay, plus 6. So you will get what number? 40? 42. So 42 will be here. Okay, 42. Sorry, 44. Okay, sorry, 44. Sorry, this is 44. So how the balance we have for the idle time? Stop. 60. Okay, minus 244. So you will get 16. Okay, clear. So please remember, okay, please make a correction. EI hash. So in between EI hash, which one the highest one? Hash first. Okay, then EI. Which one EI? The highest number, E will be I first. Then last but not least, E. E, so go on the E. So total will get 16 here. So this is how we calculate this station number 5. So we get all these things like this. Session number 1, session number 2, session 3, session 4, and session 5. That's all. Okay. So as a TM is a 5, so we can not do better than with 60 seconds on the cycle time, as I mentioned earlier. Okay. This is how we calculate. Okay, clear. Okay, how do we calculate the idle time? Please remember the formula for the idle time. Do you remember the idle time previously? So look at on our formula here. Wait, I want to show you the idle time formula. Which one? The idle time. Okay, please calculate this idle time. If we need to double check our table, is it correct or not? Okay, so we have to double check. Please put it on our formula. Okay, idle time, idle time. Okay, put it on formula first. So how do we calculate the idle time? Okay, let's see here. Okay. So what we get the idle time? Okay, idle time, idle time. IT, I follow IT. Okay, theoretical number 5. Okay, minus 260. Okay, for example. And then minus with 244. So what we get the idle time? Please calculate.
56.
56. 56 seconds. Okay, this is our idle time. Is it correct? Okay, look at on our table. Please plus the total idle time here. 20 plus 10 plus 5 plus 5 here and plus 16. Do we get the same idle time, total time with our based on our formula? So 20 20 plus 10 plus what is the other time? 5 plus 5 and then plus 16. Do we get the same answer 56? Yes. So meaning that we will get the same based on our formula and based on our table. So total time that we get here, okay, all the total time that we get here is 56. Same with our formula here, ideal time. So meaning that our table is proof correct lah. Okay? Okay, any questions so far? No question? Okay, in order to understand, I give to you a tutorial, okay, regarding to our line balancing. Okay, that's all for today. Okay, record, stop first.